Section 1. Introduction. Titans of Earth and Sky. Two mountains stand as titans, captivating our imagination. One pierces the sky, a majestic white pyramid. The other slumbers beneath the ocean, its peak a silent sentinel. Mount Everest, the roof of the world, reigns supreme in the Himalayas. Mauna Kea, the White Mountain, rises from the Pacific depths. Both mountains inspire awe. Both hold secrets. Everest, at 8,848.86 meters above sea level, claims the highest point on Earth. Its snow-capped summit beckons climbers from around the globe. They test their limits against its icy slopes, driven by an insatiable thirst for adventure. Mauna Kea, though less renowned for its height above sea level, boasts a staggering total height. Measured from its base on the ocean floor, it dwarfs Everest. Mauna Kea stands at over 10,000 meters, a colossal giant hidden beneath the waves. Its summit, at 4,205 meters above sea level, offers a different kind of challenge. This dormant volcano provides a vantage point for exploring the cosmos. Its summit, above the clouds and atmospheric distortion, hosts some of the world's most powerful telescopes. These two mountains, Everest and Mauna Kea, represent extremes. They embody the power of nature, both in its destructive and creative forces. They stand as testaments to the Earth's dynamic history shaped by geological upheavals over millions of years. Their slopes harbor diverse ecosystems teeming with life adapted to extreme conditions. Section 2. Geological giants, formation and structure. Both Everest and Mauna Kea owe their existence to the Earth's restless nature. They are products of plate tectonics, the slow dance of the Earth's crustal plates. Everest was born from the collision of the Indian and Eurasian plates. This ongoing collision, which began some 50 million years ago, continues to push the Himalayas skyward. The Indian plate, driven by immense forces, slides beneath the Eurasian plate, uplifting the landmass and creating the towering peaks. Mauna Kea, in contrast, emerged from a hot spot in the Earth's mantle. This plume of molten rock, rising from deep within the Earth, pierced the Pacific plate. Over millions of years, successive eruptions built up the massive volcano. Unlike Everest, Mauna Kea is now dormant. Its last eruption occurred around 4,600 years ago. However, its volcanic origin is evident in its slopes, composed of layers of solidified lava flows. Everest's structure reflects its violent origins. Its peak is composed of marine limestone, a testament to the ancient seafloor that was uplifted during the continental collision. The mountain slopes are a jumbled mix of rock formations folded and faulted by immense pressure. Glaciers carve deep valleys, their icy tongues sculpting the landscape. Mauna Kea's structure is more symmetrical, reflecting its gradual formation. Its summit caldera, a large crater formed by past eruptions, is now filled with volcanic ash and cinder. Its slopes are relatively smooth, covered in a layer of volcanic rock and ash. Permafrost, a layer of permanently frozen ground, underlies much of the summit region. Section 3. Cultural significance, sacred summits. For centuries, mountains have held a special place in human cultures. They are seen as sacred places, dwelling places of gods and spirits. Everest, in the eyes of the local Sherpa people, is Chomolungma, goddess mother of the world. It is revered as a sacred site, home to powerful deities. Before attempting the climb, Sherpas perform rituals to appease the mountain spirits and ensure a safe passage. Mauna Kea, too, is steeped in cultural significance. In Hawaiian mythology, it is considered the most sacred mountain. It is believed to be the meeting place of Earth Mother Papahanaumoku and Sky Father Wakia, the progenitors of the Hawaiian people. The summit is regarded as the realm of the gods, a place where mortals should tread with respect. For both mountains, cultural beliefs have shaped human interactions with the environment. Traditional practices passed down through generations have helped to protect these fragile ecosystems. However, the influx of modern tourism and development has brought new challenges. Balancing cultural preservation with economic development is an ongoing struggle. Section 4. Environmental wonders, biodiversity and climate. Despite their harsh conditions, both Everest and Mauna Kea support a surprising diversity of life. Their slopes harbor unique ecosystems, shaped by altitude, climate, and geological factors. Everest's lower slopes are cloaked in forests, home to a variety of plant and animal species. As altitude increases, the vegetation gives way to alpine meadows and then to barren rock and ice. Mauna Kea's environmental gradient is equally dramatic. Its lower slopes, bathed in tropical sunshine, support lush rainforests. Ascending the mountain, one encounters a succession of ecosystems from cloud forests to alpine deserts. The summit, a harsh and unforgiving environment, is home to specialized insects and lichens. Both mountains play a crucial role in regional climate patterns. They influence air circulation, precipitation, and temperature. Everest, a formidable barrier in the Himalayan range, affects the monsoon winds that bring life-giving rains to the Indian subcontinent. Mauna Kea, rising from the Pacific Ocean, influences rainfall patterns on the island of Hawaii. In Section 5, we explore Mauna Kea, a window to the universe. Positioned above the clouds and free from atmospheric distortion, Mauna Kea's summit offers an unparalleled view of the cosmos. This, coupled with its stable atmosphere and minimal light pollution, makes it an ideal site for astronomical observatories. Today, Mauna Kea is home to 13 telescopes, operated by 11 different countries. These instruments, among the most powerful on the planet, allow astronomers to peer deep into the universe. The observatories on Mauna Kea have led to groundbreaking discoveries that have significantly advanced our understanding of the universe. They have captured breathtaking images of distant galaxies, studied the birth and death of stars, and even searched for signs of extraterrestrial life. Notably, the twin Keck telescopes, some of the largest optical and infrared telescopes in the world, have provided invaluable data on phenomena such as black holes, galaxy formation, and the expansion of the universe. The James Clerk Maxwell Telescope, a sub-millimeter wavelength telescope, has been instrumental in studying the interstellar medium, the gas and dust that fill the space between stars. Its observations have illuminated the processes of star formation and the evolution of galaxies. Another major observatory, the Subaru Telescope, has contributed significantly to our understanding of dark matter and dark energy, the mysterious forces that govern the universe. Moving on to Section 6, we delve into Everest, the roof of the world. Everest, the highest point on Earth, has captivated the human imagination for centuries. Its icy slopes, shrouded in mist and legend, have beckoned climbers from across the globe. Reaching the summit of Everest is not just a climb, it's a feat of human endurance, a testament to the limits of physical and mental strength. The first successful ascent by Sir Edmund Hillary and Tenzing Norgay in 1953 marked a significant milestone in human exploration. Since that historic climb, thousands have attempted to conquer Everest. Many have succeeded, but many have also perished, succumbing to the mountain's harsh conditions. The thin air, extreme cold, and treacherous terrain make Everest a formidable challenge. Climbers face constant threats from avalanches, icefalls, and altitude sickness. Despite these dangers, the allure of Everest remains undiminished. Climbers are drawn by the challenge, the adventure, and the desire to test their limits. For those who make it, the experience of standing on the roof of the world, surrounded by the vastness of the Himalayas, is said to be transformative. The altitude advantage. Mauna Kea's clear skies. Positioned at over 13,796 feet above sea level, Mauna Kea's summit offers a significant advantage for astronomical observations. The air here is thinner and drier, reducing atmospheric distortion. Remarkably, the summit is also above the inversion layer, which is a layer of warm air that traps clouds and pollutants at lower altitudes. This results in exceptionally clear skies, ideal for observing celestial objects. The dry, stable atmosphere on Mauna Kea is crucial for infrared astronomy, as water vapor in the atmosphere absorbs infrared radiation, making it difficult to observe from lower altitudes. Thanks to the summit's dry conditions, astronomers can study infrared light from distant stars and galaxies, providing insights into the processes of star formation and the evolution of the universe. Moreover, the low light pollution on Mauna Kea is another major advantage. The island of Hawaii has strict lighting ordinances to minimize light pollution, ensuring dark skies for astronomical observations. This allows astronomers to detect faint objects that would otherwise be washed out by light pollution in more urban areas. Conservation challenges, protecting fragile ecosystems. Both Everest and Mauna Kea face conservation challenges, as human activities increasingly impact these fragile environments. Climate change, tourism, and development threaten the delicate balance of these unique ecosystems. On Everest, melting glaciers are creating new dangers for climbers, while also impacting water resources for downstream communities. The increasing popularity of Everest as a climbing destination has led to concerns about overcrowding and environmental degradation. Trash, human waste, and abandoned climbing gear litter the slopes, impacting the pristine environment. The presence of large numbers of climbers also disrupts wildlife and can damage fragile vegetation. On Mauna Kea, the construction and operation of astronomical observatories have raised concerns about their impact on the mountain's delicate ecosystem. The presence of large structures, roads, and human activity can disturb native plants and animals. The use of telescopes also requires energy and resources, which can contribute to environmental impacts. Exploration and research unveiling nature's secrets. Both Everest and Mauna Kea continue to be sites of active exploration and scientific research. Scientists from around the world conduct studies on these mountains, seeking to understand their geology, ecology, and climate. On Everest, researchers study the impacts of climate change on glaciers and the Himalayan ecosystem. They also collect data on the mountain's unique flora and fauna adapting to extreme conditions. On Mauna Kea, scientists conduct research in astronomy, geology, and atmospheric science. The observatories on Mauna Kea provide a platform for cutting-edge research in astrophysics, cosmology, and planetary science. Geologists study the mountain's volcanic history and its role in the formation of the Hawaiian Islands. Atmospheric scientists monitor air quality and weather patterns, contributing to our understanding of global climate change. Research on both mountains is crucial for informing conservation efforts and promoting sustainable management practices. By understanding the complexities of these environments, we can better protect them for future generations. Conclusion: inspirations for generations. Everest and Mauna Kea, two titans of earth and sky, stand as symbols of human ambition and scientific curiosity. They inspire us to explore the unknown, to push our limits, and to unravel the mysteries of the universe. These mountains, though vastly different in their origins and environments, share a common thread. They remind us of the power of nature, the interconnectedness of life, and the importance of preserving our planet's fragile ecosystems. As we continue to explore these fascinating giants, we must do so with respect and responsibility. We must balance the pursuit of knowledge with the need to protect these unique environments. By learning from the past and embracing sustainable practices, we can ensure that future generations can continue to marvel at the wonders of Everest and Mauna Kea. Facts Academy 0122 is an educational channel aimed at providing engaging and informative content. We strive to make learning fun and accessible for everyone. For more exciting adventures and educational journeys, join us on Facts Academy 0122.